Hey there everybody, I hope you're all doing well and I welcome you to my channel. Today I want to briefly talk about Monte Carlo simulations and actually do a couple of them on Python on my Google Colab notebook. But before I get started, let me preface by talking about what Monte Carlo simulations are for those of you who may not be very familiar. These are just random experiments or simulations that we do a very large number of times to approximate complicated problems that we wouldn't otherwise be able to solve analytically or empirically with measurements. So I'll just get straight into it and start by creating a simulated die roll. So first I'll import a random library, and I'll also import NumPy as well as maybe Matplot library to show you my results later. So after I have those things done, I can start with creating a die roll function. So I'll just call it roll, and all this is doing is really just choosing a number between 1 and 6 for each roll, because that's what a die does. Every time you roll it, it either gives you a number 1, 2, 3, 4, 5, or 6. Very straightforward to create it. Random.randint, choose something between the range 1 and 6 inclusive, and just return that. So to test if this works, I can just call the roll function, and you see the first time it rolled a 3, second time it rolled a 5, third time it rolled another 5, then a 6, then a 5, then a 5, then a 6, and so on and so forth. So let's build on top of this. We have a roll function. Now let's try to actually make a game. The game should be able to count the number of flips it takes to get, let's say, 3 consecutive heads. What am I saying? Heads? No. 3 consecutive 6s. So I want to keep rolling until I get the 6 result 3 times in a row. So to do that, let me just create a function. Let me call it game. And inside the function, let me give an argument called repetitions. And in this case, it's just going to be 3 as a default value. But if I wanted to, I can change this to maybe get 4 consecutive 6s or 5 consecutive 6s or how many ever I want. Depends on what parameter I put in there. Add a colon here and go into this function. So first things first, we should create a variable to count the number of rolls. Let me just say rolls is 0, because before we roll anything, of course, it's going to be 0. And then let's create something to track the number of consecutive 6s. So this is also going to be 0. And then we'll create something to track the current roll. We'll initialize it as 0 because we haven't rolled anything yet. Now we can actually begin rolling, but before we begin rolling, we need to create a while loop. While consecutive 6s is not equal to repetitions. So the reason I'm doing this is because I want to keep rolling. I want to keep passing this roll function as long as this value is not equal to the number of repeated 6s. This value has to be 3. Only then should this loop stop, because when this value becomes 3, it means we got 3 consecutive 6s. Otherwise, it means we should just keep going. Now, I can set current roll to the roll function. This is our first roll. And if current roll gives me a value of 6, then I add 1 to this consecutive 6s function. Let me just put it right underneath. I add 1 to this. But if it's not, if current roll is not equal to 6, then I take consecutive 6s and I set it equal to 0. I need to reset it. Because imagine I get 6 on the first time, and then 6 on the second roll, but then on the third roll I get a 5. Then that just completely messed up the chain. So consecutive 6s has to be reset if current roll isn't 6, which hopefully makes sense. So this loop will keep going until consecutive 6s gets to the value of repetitions, at which point it'll stop. But before we end the loop, there's one more crucial thing, one more critical thing that we gotta do. We actually need to increment rolls by 1 every time we do a roll, because This can't be 0 throughout. Every time we roll, we have to increment this by 1. Okay. Then that's pretty much done, and I just have to have a return statement. What are we returning? Well, we're returning the number of rolls. And of course, it has to be outside the while loop, because the number of rolls is only returned after we get consecutive 6s be equal to the repetitions. Okay. Let's give this a go. Let's call the game function. And by default, I don't have to pass any values because it treats it as getting 3 consecutive 6s. Let's see how many rolls we have to do to get 3 consecutive 6s. 32, 11, 17, 111, 558. So you see there's a very big range over there, from 11 all the way up to 558. This is not ideal. I want a closer number to the actual number of rolls I can expect to do before I get 3 consecutive 6s. So to do that, we actually bring in the Monte Carlo function. I'll just define it as Monte Carlo function, and all I'm really doing here is just repeating this thing many times. So I'll say num games. This is the number of times I'm repeating. And I'll set the repetitions value again, default to 3. If I want to change it later, I can change it. So let me create a list variable to store all of the rolls that are returned from the game function. We'll call this rolls counter, and it's going to be an empty list. All this is doing is just storing everything that we do in the game function. And now we actually have to repeat this game many times. So we can do that with a for loop. I'll just create a random variable called experiments. For experiments in range num games. Num games is just the number of times you want to repeat this games function. If it's 5, then this repeats 5 times. If it's 10, it repeats 10 times, and so on. And then every time it repeats, what I want to do is I want to take the rolls counter that I just defined as the empty list, and I want to append the value from the game function. And that value is just the number of rolls. So maybe, as we saw before, the number of rolls for the first one was like 11, and then 15, and then like 558, whatever. It just stores all of them in here through this for loop. And this is going to go n times, or num game times. It's just going to keep repeating. Okay, so after that's done, I can return. I have numpy, right? Yep, I have numpy. So I can return np.mean of rolls counter. This will just give me the average value of whatever is stored in here after appending, like, the games many times. So if I do this, and I actually call the function, hopefully it works, Monte Carlo, and I want 100 simulations. I want to repeat this game trial, remember this game function 100 times, and I want to take the average of all the rolls and see how many rolls I can expect until I get 3 consecutive 6s, which is this, 253.5. Let's do it again. Hopefully the next number is also close to this value instead of way off range. 240.99. That is closer than it was before. So you see these values are in the range. And we can get more precise thanks to the law of large numbers. The more times we repeat this Monte Carlo simulation, the more precise our values will get. So let me increase the number of simulations to 10,000, which is 100-fold more than the previous. It's going to take more time because there's more simulations now, but it's going to give us a value that's closer to the expected value, 259.3267. And this is way more accurate in terms of the number of decimals. We'll do it again. Let's see if the number is close to that, 259. Yeah, 255. Let's do it again. 259.27. Yeah, it was pretty much exactly the same. So this is roughly the number of times you will have to roll until you get 3 consecutive 6s. Now let's try actually graphing all of this. I had a graph over here that we can just pretty much replicate. Clear the indent like this. Let me take this and put it into the Monte Carlo function and correct all the indentation levels. And let me just alter the variables a bit. This is going to be rolls counter instead of number of heads. And flips list should be rolls counter. Alright, hopefully this works for 10,000 trials. It should give us a bar graph. Let me increase the number of bins. That doesn't seem right. That does not seem right. Number of flips should be around here when you take the average. But clearly the average is, oh sorry, it should be around right here when you take the average. But clearly the average is focused a bit more to the left side at a much smaller number, which is leaving me confused. So here the average flip count is 257, and 257 is somewhere over here. It might be because of these bigger values. Right, that makes sense. These bigger values are biasing the average. So maybe instead of doing the average, we should get the median. Maybe that'll be a better choice. Let's look at what the median value is. The median value should be much smaller than this 257 value. So let's go into here and change this to median. Graph should be the same, but the median value is going to be different. It's going to be smaller, I believe. Yeah, 181. So that's somewhere over here. And that does seem correct. Most of the values, this looks like the 50th percentile value, because most of the things in the graph are towards the left side. Anyway, that's all for this little tutorial. I hope you guys learned something, and thank you for watching. Until next time.